Today we're going to talk about domain and range of functions. Let's first start with domain. Domain are your x values. When finding domain from a graph, you're going to look from left to right. So we want to find our leftmost point. Your leftmost point here is -4. Your rightmost point is an arrow, which means it keeps going. So our domain is all values greater than or equal to -4. Our range are our y values. When we try and find range from a graph, we're going to look at our lowest to highest point. So our lowest point here, bring it to the y-axis, is 2, and our highest point is all real numbers. You have an arrow, which means that it's going to keep going all the way up. So our range would be y is greater than or equal to 2. Now I'd like you to try number 2 at your own time, pause the video, and then pick it back up. So now let's look at equations. We want to find domain and range from equations. Let's plug it into our calculators. We're going to go to y equals 2x plus 1, graph it, and we're going to sketch it. Now if I look at my graph and I want to find my domain, I can look. My leftmost point and my rightmost point are both arrows. So my domain would be all real numbers. Your range, looking at the graph, is your lowest point to your highest point. So when I look at my graph, I have, again, 2 arrows. They continue to go. So all real numbers. Now let's think about this algebraically if I didn't have a graph. We're going to look at our domain algebraically. If I look at y equals 2x plus 1, think about, are there any values that I cannot plug in for x? Is there anything that won't work? If I plugged in 0, it works. If I plug a negative number, it works. If I plug in a 1, it's going to work. Right? It's never going to be undefined. So any line we can use will be all real numbers. You're going to try number 2 on your own, so pause the video, try number 2, and then pick it back up. Number 3, let's plug it into our calculator. Follow along with me. So now let's sketch it. If I look at my parabola using the graph, I can see my leftmost point and my rightmost point are arrows. That means it's continuance using all values. My range, I'm going to have to look at my graph. Let's look at our table. Maybe it'll help us. Our lowest point there is -25. So when I look, my range, the lowest point is -25, and it's using everything above that. So all values greater than or equal to -25. Let's think about this algebraically for domain. Your domain, are there any values I plug into x that won't work? If I plug in 0, if I plug in a negative number, if I plug in fractions, it'll always work out. I can use any x value. So my domain would be all real numbers. There's nothing that makes it undefined or gives me an error. Try number 4 on your own, pause it, and then pick back up the next slide. Next, we're going to plug in to our calculators. See what our picture looks like. 1 over x. So now let's look at this graphically. if I try and find my domain, my leftmost point and my rightmost point, there are arrows, but if you notice, there's a break in the graph. There's a point that we're not using. And if you look at it, you're using all numbers except 0. And think about this. Let's do it algebraically, which we're going to do most of the time here. Right? This is one of what we call your watchouts. If it's a fraction, think about it. What can you not have in the bottom of a fraction? If you have 0, it's going to make it undefined. So what you want to do whenever you see a fraction, we want to set your denominator equal to 0. When you've set it equal to 0, figure out what it cannot be. It's all real numbers except for that value. Right? So if I had to set this up, right, and we're going to put a line to it because it cannot be that. So figure out everything it cannot be. It's all real numbers except what makes your denominator undefined. If we look at your range here, we're just going to do range graphically. Your lowest point to your highest point, again, are arrows, but there's a break in the middle there. Right? That's 0, there's a break. If you have a fraction, your output will never be 0. When I input 0 in the bottom for x, 1 over 0 makes that 0. That can't happen. So I will never have 0 there. So my range is going to be all real numbers except 0. Now you try number 6, pause it, and then pick it back up. Number 7. Let's go to our calculator. Let's plug it in. Graph it. Let's sketch it. Now looking at your domain algebraically. Well, let's first look at it graphically. If we look at it graphically, my leftmost point is 0. My rightmost point is an arrow. It keeps going. So I can say all numbers greater than or equal to 0 work. But now let's look at this algebraically. As an equation, you have to look at it. It's a radical. What can't you have underneath the radical sign? You cannot have negatives. Remember, you got imaginary numbers. Those are not real numbers. You can have 0. The square root of 0 is 0, but you cannot have a negative number. So when you're trying to figure out it algebraically, you're going to set what's underneath your radical to greater than or equal to 0 and solve it out. So if I set my denominator, that's exactly what it would be. X is greater than or equal to 0. And that is going to be your domain here. So algebraically, set it to greater than or equal to 0. Now your range, if you look at it graphically, my lowest point is 0. My highest point is an arrow. It continues. So my range is y is greater than or equal to 0. Number 8, I'm going to let you try on your own. Pause it and pick it back up. Number 9, let's plug in our calculator. We're going to do 1 over radical x sketch it. So now let's look at our domain graphically. If I look at it, my leftmost point is an arrow, but it's going straight up. My rightmost point is also an arrow, and it's going all the way down to the infinity, x values. But I'm never touching 0. So everything greater than 0 works. It gets close to the y-axis, but it never touches it. Now let's think about this. Let's change that to an h. Let's think about this algebraically. we're underneath the radical. So just like we had in the previous example, it cannot be negative. It also is now in the bottom of a fraction like we had in our example before that. When you're in the bottom of a fraction, you cannot have 0. So now we can't have 0 and we can't have a negative. So when you're trying to solve these, you're going to set your denominator to greater than 0. Similar to the previous one, but only now you're in a fraction, so it cannot be 0. It cannot be equal to 0. It would make your fraction undefined. Your range, if I look at it, my lowest point to my highest point, it's going to get very close to your y-axis, your x-axis, excuse me, but it's never going to touch. And then you have your arrow that continues all the way up. Your range is going to be all numbers greater than 0. Number 10 you're going to do on your own. Excuse me, let's change that. Your range should really be f of h. Right? Because your range is your output. So you want to make sure that's f of h.